Hi students, welcome to Technogate. This is the operating system class. In the last class we have discussed about all the scheduling algorithms. So now we will study one more disk scheduling algorithm, that is multi-level queue and multi-level feedback scheduling algorithm. Multi-level queue and its feedback algorithm. Multi-level queue feedback algorithm. Multi-level feedback scheduling algorithm. Okay. Now, what is this multi-level queue? What is this multi-level queue? We are having different processes. So this process are dividing into three types. Let some process dividing into system processes. Other is now interactive processes. Now third one is batch process. Okay. What is the system process, what is interactive process, what is batch process? Why should we learn about this? What is a system process? Now system process is nothing but the process which will be executed by the system itself. Okay, the process which executes by the system itself. Which executes system itself. Like scheduling time. So time automatically the time will be done. So that is a system process. Now what are the interactive processes? So whenever the implementer or the user have to be interacted with the application to complete its execution, like Word. User interacting with applications, like Word, preparing a Word document, preparing a PPT, preparing a PDF document, anything can be done in the interactive process. Now what is the batch process? So in this batch process many different jobs are there. Okay, I said you in the before also, different jobs like job 1, job 2, different jobs are categorized into one batch. So different jobs are categorized into one batch based on the similarities. So this may run in the foreground process or also background process. So remember this system process, interactive process and batch process till here. Now let us see this diagram. All this system process and interactive process and this batch process, all this process are connected to CPU. When all this process are connecting to CPU, all this process will be executed. So while executing this process, we have 4 to 5 different rules. What are these rules when the process must be executed? So this system process must be highest process. So this system process should have highest priority and this batch process should have lowest priority. This system process should have highest priority and interactive, not only system process, interactive process, batch process. These may be varied, like interactive process may come first, system process may come first, batch process may come first. Actually why this multi-level queue came into picture? So whenever we are processing into a ready queue, from this ready queue processes are entering into the running queue. So why can't we divide the ready queue? Why we are only applying the same scheduling algorithm to all the processes which are waiting in the ready queue? So why? So for this question to provide the answer, this multi-level feedback scheduling algorithm came into picture. So in order to apply, instead of applying all the scheduling algorithms in the same way for each and every process, so we can apply different algorithms for each and every process. So in that way, can we assign the CPU properly? Will all the different process will be executed or not? Will the answer for all these questions will be given in this multi-level feedback scheduling algorithm. So how this multi-level feedback scheduling algorithms is done? So these are all the rules. What is that? The first process which you are taking, that should be having highest priority, and the one at the last, it should have lowest priority. And for each and every different set of processes, it should be assigned with the previous algorithms. Let it be FCFS, here round robin, here SJF. Any different algorithms can be taken, and it should be assigned for any of the different processes. So while assigning these processes, it may be different, whether I took FCFS for the system process, I took round robin for interactive process, and SJF for batch process. We can take any different algorithms for any different process. That is depending upon the user or the implementer. He can take it in any way. So after assigning the algorithms to each different process, now what are the different ways? So we have to ask, this is the first rule, that the first rule is it should be highest priority and it should be lowest priority. And the second thing is each and every process should be assigned with the different algorithms. Now the third thing is, until and unless we in the system process, let there are be three processes, P1, P2 and P3. Until and unless all the process in the highest priority complete its execution, it should not enter into the interactive process. It should not enter into the lowest priority process. Okay. So whenever this P1, P2, P3 process complete its execution, whenever these three processes complete its execution, then only it should enter into the interactive process. So if it is left, there is only something you some algorithm you took, for example FCFS algorithm itself, or round robin algorithm itself, by following that algorithm, if any process left with execution, then it should be brought to the next lower priority process. So then similar way, after P4, P5 and P6, whenever these three algorithms are there, these three algorithms complete its execution, then only move to the batch process. Okay. Now P4, P6, P7, P8 and P9, these three processes are waiting in the batch process. So first they have to complete this process, then interactive process, then come to batch process. So there is longer starvation period for the batch process, for the process which are waiting in the batch process. These are waiting for the longer time. Not only that, so the fourth rule is the thing, even after completing the process, P1, P2, P3 process completed its execution in the system process, it entered into the interactive process. Then again one more process, let it be P10, entered in the system process. Okay, P10 entered in the system process, then it has to be the process P4 is executing in the interactive process. This P4 process should be interrupted, it has to stop its execution, then it should assign to the P10. So it should go to the system process and P10 process should be executed. So this is the thing, it works like a primitive mode whenever it is working in the interactive process. So P4 is executing in the interactive process. After completing these three processes only, it came to interactive process and it is executing P4 process. Then meanwhile P10 process, P10 is a different process, came into the system process. Then what happens? It is having highest priority than the P4. So P4 should be interrupted. P4 should stop its execution, it must enter into the ready queue and P10 will come into the running queue. These are all the rules for the multi-level feedback scheduling algorithm. Let us see one example. I took three priorities itself. Let this be system process, this be interactive process and this be batch process. So for this process I took the round robin algorithm as time quantum is 5. For the round robin algorithm we must assign the time quantum. So I assign the time quantum as 5. Now in this, after this, so second for interactive process also I assign the round robin algorithm. So the time quantum is 10. Then I assign with first come first serve algorithm for the batch process system. So there is no time quantum, it is based on the arrival time, that's it. So all these processes are connected to CPU. Now what happens? Different processors are assigned in the for this process. For example, P1 is a process which is having 15 as a burst time. What is the burst time of the P1? 15. So it will enter, that is there in the ready queue of this round robin algorithm. So it but the time quantum assigned for the P1 process should be only 5. So it cannot complete its execution in the system process. It cannot complete its execution. Okay. So will the P1 complete its execution? No, P1 will not complete its execution in the system process, whereas then it will enter into the interactive process. How much execution time is there now? P10. P1 is having, so 5 milliseconds it's completed in the system process. Now in the interactive process it is assigned with time quantum as 10. Its burst time is also 10. So P1 will be finished in the interactive process. Okay. Let the other example, let P1 will be having 20 as a burst time. So 20 as a burst time. So it completes 5 milliseconds in the system process. So it is left with 15 more seconds. Okay. Next it will be entering into the P1. When it is entering into the P1, it's still left with 5 milliseconds. So it will enter into the batch process, which is scheduled with FCFS algorithm. By FCFS algorithm it will be executed. So in this way, whenever this process completes its execution in the system process, then only it should enter into the interactive process. Next lower priority, like that. So if this is like in a non-primitive mode. When we take the primitive mode for a multi-level feedback algorithm, so when different process comes into this priority, while the process which is running here in the interactive process, it should be stopped or interrupted, then the algorithm will go back to the system process and it will be executed. Here once the process finish its execution, then will again come into interactive, then batch process. This is all about multi-level scheduling algorithm. So why we are using this multi-level feedback scheduling algorithm, even though we have many algorithms like FCFS, round robin, short job first algorithm in different modes, because to separate the ready queue, to separate the ready queues in different levels. This is level 1 of ready queue, this is level 2 of ready queue. What these levels are? These levels are this. First system process, interactive process and batch process. We have taken this ready queues into different levels as system, interactive and batch process, and we are assigning with the different algorithms. So it provides the answer for one more question also. What is that? Why can't we use different algorithms for different process which are waiting in the ready queue? For that question also, multi-level feedback scheduling algorithm provides an answer. This is all about multi-level scheduling algorithm.